My interest in physics actually began as a child. It has three parts. The first part was about age 6 or 7. I had just learned how to read, and my dad brought home some books on space travel. I was born in 1950. Nobody had ever been in space. So when I was reading about space travel, this was like, the far edge of what one could think about. And I became very excited, and I thought about becoming an astronaut. About a year or so later, I was looking through some books my father had brought home. In those days, we didn't have the web, so when you had to do homework, you had to use these big things called Encyclopedia Britannica or whatever other encyclopedia your parents were kind enough to buy for you. So I was paging through this one volume, and I saw something odd. It had an equal sign in the middle, it had a bunch of plus signs, but the rest of it was literally Greek, and I couldn't understand what it was. And even as an 8 or 9-year-old, I recognized it must be some kind of arithmetic, I thought, because I saw an equal sign. But I wondered, could I ever understand whatever this thing was? And then finally, when I was in my junior year of high school, I took a physics course. I had a fantastic physics teacher, a gentleman by the name of Mr. Freeman Coney. And one day in class, he showed me the closest thing to magic I have ever seen in my life. He did this experiment where you take a board and you tilt it, and you let a ball roll down the board. And then you take a stopwatch and time it. And it turns out that the distance the ball travels down the board is proportional to the square of the time on the stopwatch. And he wrote this equation, and it describes what's going on. I was thunderstruck because I had always thought of mathematics as being an element of imagination. It was just like making up stories about space flight or reading comic books about superheroes. It was a game of play for me, and it was always inside of my head. But to see mathematics suddenly leap outside of my head and be in the world around me, I was like, how can this possibly be? And so, like I said, for me, this is the closest thing to magic I've ever seen. And at that point, I knew it was physics that I wanted to do, not just science. So we live in a universe, apparently, where equations describe things that go on around us. And so there's one set of equations that describe things like electrons. There's an entirely different set of equations that describe particles of light. And so the idea of supersymmetry is that maybe you can switch the equations a little bit. And, that's what theoretical physics is all about. We're always asking the what-if question. And so when we talk about supersymmetry, we're talking about a world where the equations that we see in the laboratory can be switched, and we might find some new particles or new effects out in nature. And that's what I decided as a young graduate student was the most interesting thing I could pursue as a theoretical physicist. Well, first of all, I don't actually recommend students go into a science career unless they think it's going to be fun. For me personally, I couldn't avoid being a scientist because it was just one of the most fun things I had ever discovered as a young person. So the first thing is I tell students, whatever you want to have in life, and I'm sure most people want to be successful at some level, the first secret to success is asking yourself, what is it that's closest to my heart? I know that might not seem like the right place to start, but if you start with that question, then you're likely to find something that you'll fall in love with. And if you fall in love with doing something, it means you'll do it automatically and you'll do it a lot. And if you do something a lot, you get really good at it. And that's actually how you get to be successful, by being really good at something. So it actually starts by asking, what's closest to my heart? We're now at a point where some really interesting things are going on. First of all, in Geneva, Switzerland, there is a scientific laboratory called CERN, C-E-R-N. And at this laboratory, they have the world's most powerful particle accelerator. In fact, it's sometimes called the Big Bang Machine. And if any of your viewers have seen something like Angels and Demons, the movie, that big scientific installation in the movie is CERN. And so what's going to happen at this location are a set of experiments where physicists are going to actually see if these mathematical switchings that we talked about earlier, whether you can detect that in the laboratory. If that happens, then we will know that our equations are not just mathematics, but they're also a description about our universe. The other thing that's going on in my career is a little bit weird, and I'm almost a little bit loath to talk about it. I don't know if you or your viewers, and I'm sure some of them have gone to see the movie The Matrix. But in The Matrix, there are people like us, and they live in a world that's kind of like our world. And the only thing about their world is it's not what it seems, because the totality of everything that people experience is generated by a computer. So it's a virtual reality. Well, some of my research can be interpreted to suggest that we live in such a world. And that's just kind of mind-blowing. So by studying the equations that, that I've been knocking around with forever, in the last 5 or so years, I've been able to show that hidden inside of these equations, there are computer codes. They're the kind of computer codes that make browsers work. And so if the equations that describe our reality have computer codes hidden in them, that's just kind of weird. And in fact, it's so weird that I like to tell people, let's go back to the Matrix movie. If there were physicists in the movie and they want to know they were inside the Matrix, how could they do that? Well, one way might be to try to detect computer codes in the equations that describe their world. But that's what I've just proposed.